Hi, my name's David Brooks, and this presentation will be on the evolution of Homo sapiens dentition. To start off, dentition is defined as the arrangement or condition of the teeth in a particular species or individual. But who really cares about this? Well, human dentition is an incredibly important area of the body that plays a large role in individuals' daily lives. People use their teeth to show confidence through a smile, eat, and even vocalize certain sounds. In the United States, around 90% of adults get at least one cavity or caries per year. Caries, if left untreated, can lead to the loss of the tooth, severe pain, or even health issues such as death. Through understanding the evolutionary process of how teeth came to be, it is possible to learn how to better take care of them in the future. If we go way, way back, we can begin to talk about the origin of dentition. Anciently, jawless fish had their teeth structures on the outer surface of their bodies. It took approximately 500 million years for evolution to work on those early creatures and begin to slowly migrate the dentition to the inside of the body. According to a study done by Dr. Kosulakou, professor at Aristotle University of Thessaloniki, she showed that the oral cavity actually has evidence of evolution, that the reptiles evolved into the mammals we see today. This evidence can be seen in each side of the skull of reptiles and mammals, as there are a couple of openings called temporal fenestrae. These are located behind the orbit and can still be found in different forms in animals seen today. This is the location of attachment muscles used for mastication, or in other words, chewing. In addition, some have wondered whether ancient teeth had a different coloration than modern teeth, due to how brown they are when they're pulled out of the ground. This brown coloration is actually due to fluorescent material from the ground being leached by the teeth, thus giving it its brown coloration. Some of our recent common ancestors, such as the Neanderthals, may not have been so different than us after all. Some scientists believe that Neanderthals had molar tooth enamel that was much thinner than the enamel of the Homo sapiens today. The thinner enamel was thought to be evidence of faster crown formation rate, which would signify a big difference from modern humans and could mean that there was a shorter maturation period between Neanderthals and modern Homo sapiens. Some scientists have interpreted the thinner tooth enamel to equate to suboptimal health of these individuals. However, further research has shown that Neanderthals actually have thicker enamel than modern Homo sapiens and were no more physically stressed than foragers of today, like the Alaskan Inuit. Figure 1 shows relative thickness of Homo sapien molars, molar 1, molar 2, and molar 3, the wisdom tooth, compared to Shanidar, which is just another name for Neanderthals, and a comparison group, Pan troglodytes, also called chimpanzees. From the graph, we can conclude that Neanderthals are very closely related to Homo sapiens, or in other words, that the relative thickness of Homo sapiens and Neanderthal dentition is relatively the same. It is also believed that Neanderthals may have also had a stronger bite force than either Upper Paleolithic or Homo sapiens of today. There have been many driving forces of the evolution of Homo sapien dentition, one of those being natural selection. Natural selection has played a large role in shaping Homo sapien dentition. One of the possible ways was that for our ancestors in Africa, they went from a tropical climate to a savanna climate. As this happened, the food source greatly changed for them. This, along with other climate changes in history, may have caused the dentition to change and evolve along with the environment. Another key role in Homo sapien dentition is sexual selection. It has been shown that facial symmetry plays a large role in a person's attractiveness. This may have received its roots from Homo sapien ancestors selecting mates based off of, or at least partially based off of, facial symmetry because it was a sign of good genes. That evolutionary bias of selecting towards symmetry of dentition has given rise to $1 billion industry today known as orthodontics, where we still equate symmetry of dentition with attractiveness. One other factor has been hunting, gathering, and creating tools. As tools were created, meat and food could be mashed up and more easily chewed and swallowed. Another key factor was fire. As fire became a common tool, our early ancestors could cook meat, making it much easier to chew. As meat and food sources became much easier to chew, the bite force of the extended maxilla and mandible, or jaw, did not need to be so great. So this may be one reason why Homo sapiens of today and our ancestors have a different size of their jaw, and Homo sapiens of today, their jaw is much more sunken into the face because we don't require that same bite force that used to be used anciently. Baby teeth, also called primary or deciduous teeth, are another great example of Homo sapiens evolution. Now, there are animals that develop dentition once in their lifetime, such as rats. Others, like birds, do not develop dentition at all, and some, like sharks, develop dentition their entire lives. Why is it that Homo sapiens only developed 2 sets of teeth? There are even animals whose embryo possess tooth germs, but those tooth germs undergo apoptosis before birth. According to the American Dental Association, baby teeth help children to speak, chew, and hold a place on the jaw for permanent teeth, which are growing under the gums. The American Dental Association has also said that if a baby tooth falls out too early or fails to develop, this may cause problems for the adult teeth coming later. It's possible that the evolutionary purpose of baby teeth is that Homo sapiens do not need more than 2 pairs or 2 sets of dentition. The first is essentially training wheels for the reasons that were previously discussed, and the second, if taken care of, are meant to last a lifetime. The third molar, also known as wisdom teeth, erupt around the age of 18 and can be seen circled in red in the X-ray shown. The reason Homo sapiens have them can be found in the evolution of the human mandible and maxilla. Anciently, these bones were used to be much longer, which gave room for the third molar or wisdom tooth to develop. This may have helped with chewing efficiency, giving older adults another tooth to use to chew with and begin food digestion. The molars can generate the most bite force because of how close they are to the temporomandibular joint, or TMJ. This means they handle the most heavy-duty chewing and may have been most likely to wear out quickly. If there are teeth that are saved until later in life, it would give the advantage of having another set of teeth to take the brunt of the most difficult chewing and could reduce stress on the molars that develop earlier in life. As species have evolved to the Homo sapiens today, over those millions of years of evolution, the face has sunken in. The picture of skulls as seen on the slide are a modern Homo sapien on the left and Australopithecus afarensis, an early ancestor to the modern Homo sapien, and that's shown on the top right. It can be seen how the Australopithecus afarensis skull have a much longer jaw, giving them more room for the third molar. It would make sense that if the human jaw were getting smaller and there was no longer room for the third molar, then the third molar should eventually be lost. Although it was not easy to find hard sources on the percentage of population born with fewer or no wisdom teeth, sources tend to agree that somewhere around 35% of the population are born without wisdom teeth. They are examples, wisdom teeth are, of vestigial structures, since they no longer have a functional role in Homo sapiens, but used to in our ancestors. Since the rise of modern medicine, dentistry and specifically oral surgery, have oral surgeons have been able to remove wisdom teeth from thousands of individuals. Since this is a relatively easy procedure, it is possible that these surgeons are essentially removing the third molar before natural selection can act on the population. For this reason, it is not more advantageous to be born without a third molar because of how easy it is to remove it. It would be fascinating to see a long-term study tracking the percentage of people born without third molars. It is possible that in parts of the world where oral surgeons are not common, there will be a decrease in individuals with third molars because of natural selection working on these populations. However, in areas like the US, it is possible that the rate of individuals born without third molars will stay the same because oral surgeons can remove so easily the third molar. So being born without a third molar does not necessarily give that individual any sort of evolutionary advantage. According to a study done by Dr. Boyd, a doctor of dental surgery, it is possible that crowding and malalignment were not as prevalent in prehistoric predecessors to our species. In his study, he says that Egyptian skulls, according to fossil evidence, show that class 2 and class 3 malocclusions did not exist in large numbers until around the 1800s. In the picture shown on the right, it can be seen that the prehistoric skull on the left has much healthier dentition than the more modern skull found on the right. Dental caries are something that have haunted Homo sapiens and their ancestors for a long time. There was even a Paranthropus robustus skull dating back to around 1.5 million years ago that was found to have had caries. It seems, however, that caries were not as prevalent until about 1,000 years ago. One of the reasons for this is the production and distribution of sugarcane. Teeth are critical and play a role in our daily lives. Modern medicine has done miracles in prolonging human life and giving a higher quality of life. Evolution has played a role in shaping dentition from the beginning. We can see that in the genius of the primary teeth and how the third molar is an example of a vestigial structure. There needs to be more research on dentition and how chemicals like fluoride can help protect enamel. Evolution, through millions of years, has developed an incredibly durable and strong material that should last a lifetime. If individuals can better care for their dentition, then many health crises can be averted, and the overall population will be happier and healthier. A healthy oral cavity can help someone get their dream job because of added confidence, and even help in some of life's most basic functions like eating. Dentition of today's Homo sapien is a modern marvel of evolution.